Hello everybody, in Module 3 I discussed models of agency problems. Module 3 has 6 lessons. Today we focus on Lesson 6, credit rationing, which is the application of the verse selection models in a banking setting. Given that we do not talk about banking setting in all of our other modules, I feel it's good to talk about banking setting in this lesson. In the models, borrowers have more information about the nature of their project than lenders, hence the adverse selection problem. That results in lenders providing less loans relative to first best. That is credit rationing. This is similar to the logic that we discussed in the previous lesson, when a seller produces less units of goods relative to first best. In the first model, there are two types of borrowers, more risky and less risky, or safe firms. Their projects have the same NPV, but banks would cater more to more risky borrower because the upside return is higher and they can charge higher face value. However, to prevent more risky borrowers from mimicking, the bank is going to ration credit for less risky borrowers. This is similar to what we discussed in the previous lesson, when the seller is going to choose less units of production for buyers with low valuation to prevent buyers of high valuation from mimicking. In the second model, again, there are two types of borrowers. The only difference is the risky borrower now have a negative NPV, and the less risky or the safe ones has positive NPV. In this case, banks only want to lend to less risky borrowers. However, we know from adverse selection that more risky borrowers have a tendency to mimic less risky borrowers. And when the prior probability that the borrower being more risky is sufficiently high, the bank may decide not to lend to anybody. The adverse selection results in complete credit market collapse. Now let's look at the model. There's a continuum of borrowers. Each borrower is endowed with a project. The project requires some investments upfront, normalized to 1. The project generates a random return x. When the project is successful, x equals r. When the project fails, x equals 0. And the magnitude of r depends on the type of the borrowers. The borrowers, they have no wealth, and so they have to obtain the financing from a bank. There are two types of borrowers, as we just mentioned. There is a risky borrower, and then there is a safe borrower, or more risky versus less risky borrower. They all have the same NPV, and the NPV is positive. The safe borrower has a higher probability of success, and conditional on the project being successful, the return for the safe borrower is lower. Borrower knows about their type. The bank only knows that the borrower is of safe type with some probability beta. The bank does not have enough funds to fund every borrower, but the bank does have sufficient funds to lend to both types of borrowers in principle. Now let's look at the first best. First best is the case of no private information, which means that the banks can observe the types of borrowers. In this case, the bank will lend out all their funds to borrowers who have positive NPV project, because you can observe the types. And the bank will set the face value to be equal to the return of the project. The project is successful. And we assume that the bank has all the bargaining power. And in this case, because the two types of borrowers have the same NPV, the bank is indifferent between lending to whatever type of borrowers. Now let's look at second best, the case when the borrowers' types are their own private information. In this case, the bank has to offer contracts that are incentive compatible, as we discussed in the previous lesson. In this case, the bank offers funding with probability xi and requires a face value of di. So the contract is specified by xi and di. And the contract solves the problem to maximize the bank's expected payoff. As you can see here, because the bank does not know about the borrower's type, so the bank cannot maximize its payoff for each type of borrower, but the expected value. And then subject to xi is a probability, so it has to lie between 0 and 1. And then the IR constraints for both types of borrowers. And then the IC constraints for both types of borrowers. And then the funding constraint. The bank only has alpha amount of funds. Notice that for the IC constraint, let's focus on the IC constraint for the safe borrowers. The left-hand side is the expected payoff for the borrower from choosing the contract for the safe borrowers. And the right-hand side is the expected payoff for the safe borrowers from choosing the contract for the risky borrowers. You're going to see for the safe borrowers, PS and RS depend on their type, but X and D depends on the type of contract they chooses. As in the previous lesson, we can similarly show that the IR constraint for the safe type and IC constraint for the risky type binds, because you're concerned about the risky type mimicking the safe type. So the risky type can pay less. And then you're concerned about the IR constraint for the safe type, because the safe type is not as keen as the risky type in borrowing from the bank. Those two constraints binds give you those two equations as listed on the slides. And so we can insert those constraints into the objective function, and the objective function becomes something like what has been described on the slides. We can see the objective function is going to be increasing in XR. And because XR is a probability, the maximum value you can obtain is 1. So XR equals 1, which means that there's no rationing of risky borrowers. The bank is going to lend to all risky borrowers. And the objective function may or may not decrease in XS. So we're going to see that under certain conditions, the objective function is decreasing XS, which means XS equals 0. Under some other conditions, the objective function is increasing XS. XS is whatever the amount of funding the bank has left after funding all the risky borrowers. Regardless of the outcome, there will be distortion of funding provided to safe borrowers. And again, the logic is to prevent risky borrowers from mimicking the safe borrowers. In the second type of model, if we assume that the safe borrowers have positive NPV, but the risky borrowers have negative NPV, and if we assume that beta is sufficiently small, then we're going to have an equilibrium. XR equals 0 and XS equals 0. The bank is not offering funding to any borrowers. There's a complete financial collapse. And the reason is the bank wants to lend to safe borrowers because they have positive NPV projects. However, risky borrowers are going to mimic to be safe borrowers. When beta is too small, the prior probability that the borrower being safe is too small, then the cost of trying to avoid risky borrowers from mimicking safe borrowers due to adverse selection is too large. The bank would choose not to lend to anybody. Before we end, let me briefly discuss the insights from continuous type adverse selection models, because in the previous lesson and in this lesson, we're all talking about binary type adverse selection models. There can only be two types. The general intuition from binary type adverse selection models extends with continuous types. In general, only the lowest type has binding IR constraint. The lowest type, the expected payoff, is the same as the reservation utility. All higher types, they're going to get payoff that is higher than the reservation utility. Recall that in the first best, if we assume that the principal has all the bargaining power, then all the agents, regardless of their type, obtain their reservation payoff. So under adverse selection, all higher types, they can obtain some information rent. And only the highest type, they have undistorted allocation. Their allocation is the same as the first best. All lower types allocations, they're distorted to prevent the highest type from mimicking those lower types. And there is a trade-off between allocative efficiency and rent extraction. For example, in the buyer-seller case that we discussed in the previous class, we're going to provide less goods relative to first best to low types in order to reduce the rent extracted by the higher types. So it distorts allocative efficiency to reduce rent extraction. The IC constraints are going to be more complicated because there are continuous of types. So there are continuous of IC constraints. And we're going to discuss how to simplify those constraints in Module 5 when we discuss the example of the real effects that utilizes those continuous type adverse selection models. So to conclude, adverse selection models applied in a banking setting results in banks rationing credit or a complete credit market collapse. When borrowers type their private information, banks are going to ration credit to safe borrowers to prevent risky borrowers from mimicking them. When the probability of a borrower being risky is too high and their project is negative NPV, then the bank is not going to provide any credit because the cost of avoiding risky borrower from mimicking safe borrower is too high. That results in a complete credit market collapse. If you want to test your understanding for this lesson, a review quiz of this lesson can be found at the link provided in the slides. Thank you very much.